So we were studying motion of an object in a plane, in which we have studied displacement, velocity and acceleration, and instantaneous velocity and acceleration. All those things we have studied. Theoretical part is over. So today I am going to take some numericals so that the theory and numerical in the combination things will be more clear to you. See, this is a question. If the position vector at any instant of a moving object in a plane is given by r vector is equal to 3ti plus t cube j, then find the magnitude and direction of velocity and acceleration at t is equal to 1 second. So see, concept is clear. Position vector is given, that is 3ti plus t cube j. What is the significance of this? It is the position vector. Its component along x-axis and y-axis are 3t and t cube. I is the unit vector along x-axis and j is the unit vector along y-axis. So it is something like this. You see, in this direction unit vector is I, it is x, and this is y, unit vector is j. This is the point at any instant t. This is the position vector. So this is, and this is the magnitude. Suppose this p, this is o, it is a, and this is b. So this OA is the magnitude along x-axis, that is 3t, and along this is t cube. Means this position vector is the function of t. I have drawn this for the sake of your understanding. You need not to draw this while solving the question. R is given, that is the position vector. R we know. Instantaneous velocity is met at that particular point. At this point, whatever velocity we will getting, that is the instantaneous velocity, and that we get by dr by dt. Means we will differentiate this, then we will get velocity. So for velocity vector, what is velocity vector? That we know, that is dr by dt. Means we will have to differentiate this with respect to t, then we will get the velocity. That we know, right? So this we will differentiate. Therefore, differentiation of this. Therefore, dr by dt is equal to, if we differentiate this, so ij will remain as it is, 3t will be differentiated. So 3 is constant, 3 will remain as it is, t is differentiated, then differentiation of t is 1. So into 1, and that is I, plus differentiation of t cube with respect to t is 3t square, and j will remain as it is. So therefore v vector is equal to dr upon dt, this one, that is 3i plus 3t square j. Velocity we got, right? And this velocity at particular time, and we want this velocity at t is equal to 1 second. Therefore velocity vector as t is equal to 1 second, that is equal to 3i plus 3, t is equal to 1 square, and j. Clear? This is in place of t, I have put 1 second. So this is equal to 3i plus 3j. 1 square is 1. That is v. Of course, at the t, 1 second. This is the vector along this, along x-axis, along y-axis. So magnitude we know. Magnitude, that is magnitude of velocity vector, that is simply v, that is equal to under root this square plus this square, that is 3 square plus 3 square, that is under root 9 plus 9, that is equal to under root 18, that is 3 under root 2. If unit is not given, so we will simply write this much unit. How did we write this? This is from that I will write V vector is Vxi plus Yj. Right? If V is equal to Vxi plus Vyj, along x-axis magnitude is Vx, along y-axis magnitude is Vy, then magnitude of this vector, that is V mod, that is equal to V, that is equal to under root Vx square plus Vy square. This we are getting how? That will have to be understood. So that can be understood like this. All these figures I am drawing for your understanding, right? And try to get it. So suppose here this is the velocity vector v bar, right? And it's x-axis and y-axis. Along x-axis, along y-axis magnitudes are given. So we can write, suppose this is the magnitude, that is A, B, C. So this is x-axis, this is y-axis, this is the motion, and this is the direction of velocity. Its x component along x-axis is this, along y-axis is this. So magnitude we will take, so mod V, that is equal to V, that is equal to this length, simply AB length. Of course it is 90 degrees. I am explaining just because one problem is equivalent to hundreds problems if you have understood the concept. So AB is a vector, AB is the magnitude of this velocity vector, right? AC is the component along x-axis and CB is the component along y-axis. So this vector AC vector is the component along y-axis, AC vector is AC, and that is equal to Vx. According to this, along x-axis magnitude is Vx. So AC is, this is Vx. Similarly, this vector CB, right? That is equal to CB length, that is equal to Vy. Here I have written vector. Here simply AC means this tells the magnitude of this, means this length. Similarly CB, CB is the vector, but CB is simply the length, that is Vy. This is Vy. Now ABC is the right angle triangle, then AB will be what? Under root AC square plus CB square. Therefore AB is equal to under root Vx square plus Vy square. This concept is used over here so that we got the magnitude of velocity. Is it clear? I explained it. For solving the problems, you need not to make the figure every time. For the sake of your understanding, I have drawn the figure and I made you understand. So velocity is known, and now I will find the direction. Direction means this is the direction. Suppose this is theta. Then what is the direction? So along with x-axis, how much angle does it make? So we will get, that is simply tan theta is equal to Vy upon Vx. Tan theta will tell the direction, Vy upon Vx. That we will find the direction over here by putting this is Vy and this is Vx. So we will find the direction as well. Tan theta, as per the definition, V is equal to 3i plus 3j, and that is after t is equal to 1 second. So it is Vx, it is Vy, so tan theta is equal to Vy upon Vx, that is equal to 3 by 3, that is equal to 1. Therefore tan theta is equal to 1 means it is tan 45 degree is equal to tan 45 degree, because tan 45 degree is 1, that you already know. Therefore theta is equal to 45 degree, means in which direction this velocity is, magnitude is this, the direction is 45-degree making the angle with x-axis. So therefore the velocity is making an angle of 45-degree with x-axis, and the magnitude, that is v is equal to 3 under root 2 unit. Now velocity factor is clear, magnitude and direction we found. Now we have to find the acceleration. Velocity is known, that is 3I plus 3t square j. Again velocity is in terms of time. So if we differentiate it once again, we will get the acceleration. Therefore acceleration is equal to dv upon dt. Again we are differentiating, that is 3. I and j will remain as it is. 3 is a constant, and constant term, if it is being differentiated, its value is 0. So this is 0I means simply 0 plus 3 into t square. If it is differentiated with respect to t, we get 2t and j. So therefore acceleration A is equal to 6tj. Right? So acceleration at t is equal to 1. At t is equal to 1, that is equal to 6 into 1j, that is equal to 6j. So 6j means magnitude is 6 in the direction of y. So magnitude of acceleration is equal to, at t is equal to 1, that is equal to 6 unit. And the direction, and this is denoted by simply a, so a is equal to 6 unit, and direction, the direction of the acceleration is along y axis, because there is no x term, the I term in this. So direction will be along j, that is unit vector along y axis. So you will write the direction is along y axis and the magnitude is 6 unit. So concept is clear. That is more important. Once the concept is known to you, the number of problems you can solve. So I always try to make you understand the concept related to the problem. That is more important than the solution. Remember this. Here I try to explain the concept we are using. It is very important, and I hope it is clear to all of you. Then wish you all the best. Take care of you and remember this.